Welcome to Online Algebra 2 class. This is Mr. Gongora, and tonight we are going to be talking about section 6-4, Rational Exponents. In this section is a lot of fun, but it can also be very confusing. So first, we should think about what this actually means. What's a rational number? What's an exponent? Well, a rational number is any number that can be written as a fraction. And exponents, we know, are repeated multiplication of the same thing. So in this section, we're not going to be dealing with exponents like that. We're going to be dealing with exponents like this. Exponents that are rational. Exponents that are fractional exponents. Okay? And our objective here is to simplify expressions that have these rational exponents. And basically, what we need to know is that we can write a radical expression in an equivalent form using a fractional rational exponent instead of a radical sign. So all these things mean is it's some sort of radical expression. Instead of making a sign like this with the variable underneath, we're now going to change this to a fractional exponent. Okay? So let's think about this term. Okay? So if a to the x is equal to the fourth root of a to the third, that means that this thing, or that means that a to the x 4 times, when I multiply it 4 times, that's what fourth root mean, is a to the third. So we can say that this is true. Okay? I can then add all these exponents together and get a to the 4x is equal to a to the third. And by definition, these two exponents must be the same. So we can say that 4x is equal to 3, and that x, my exponent, is equal to 3 over 4. Okay? So that was actually a pretty long way around to show that this is true, that the fourth root of a to the third is the same thing as writing a to the 3 over 4 power. Okay? And in general, the nth root of x to the first power, okay, we'll talk about other powers later, but in general, the nth root of x is always equal to 1 over x to the 1 over n power for any positive integer n. So we're only going to deal with positive exponents here for now. Okay? So, like the radical form, the exponent form indicates the principal root. So we don't put plus or minus, right? We just do the principal roots. Square root of 36. That number right there in the index is a 2. So this becomes, another way to write this is 36 to the 1/2 power. Cube root of 64. Another way to write that is 64 to the 1/3 power. Fourth root of 16. Another way to write that is 16 to the 1/4 power. Okay? These numbers, the index of the radicals, become the denominator of my rational exponent. Okay? So, what's the simplified form of these expressions? Well, the denominator indicates the root. So basically, all I'm doing here is I'm taking the third root of 216. And the third root of 216 is 3 numbers that multiply together to give you 216, and it's 6 times 6 times 6. So this is 6. Okay? So when we have a number to a fractional exponent, the denominator of that is equal to the root. Okay? We also can combine like things if they're the same, like radicals, right? So I could rewrite this as radicals. So this could be the square root of 7 times the square root of 7, which is the square root of 49, which is just 7. Another way to have done this would be to use some of our properties of exponents, and we could actually take these two and add them together because they're the same base. We'll get to that a little bit later. All right? But for now, we can put like radicals together because they're both square roots. These are both fourth roots. I can do the same thing. So the fourth root of 5 times the fourth root of 125. I can multiply these together because the index is the same. That gives me the fourth root of 625, which is simply 5. Because 5 times 5 times 5 times 5, 4 times, is 625. Great. Let's try a couple of the guided problems. 64 to the 1/2 power is the same thing as saying the square root of 64, right? It's just a fancy way of saying the square root of 64. And of course, the square root of 64 is 8. Here, we have the square root of 11, and the square root of 11 multiplied together gives you just 11, right? It turns into the square root of 121. Or I can just add these exponents together because they have the same base, and I get 11 to the first power. Here, these are both square roots, so it's the square root of 3 times the square root of 12, which gives me the square root of 36, which is simply 6. Okay, so the most important thing to remember in this first type of problem with these fractional exponents is the denominator is the index of the radical. It's the root you are going to take. Okay, so then it follows from law of exponents that if you have a power to another power, you multiply those exponents together, which means that this is true, that 1 over n is equal to the nth root of a, but as soon as we throw a number underneath here, the numerator becomes the exponent. Now, you could do this either this way or this way, and it might actually be hard to see the difference right here. This says raise a to the mth power and then take the nth root. I would say that is not the best way to do it because when you, and you'll see this with the numbers in a second, when you raise something to an exponent, you make the number bigger. When you take the root of something, you make the number smaller. It's probably easier to do this first. Let's actually do an example of that. So, for example, let's do this. Let's do the 8 to the 2/3 power. Okay. Now, I could, if I wanted to, let's rewrite this as root exponent, the third root of 8 squared, or the third root of 8 squared. Either way, it's the same thing. I either do this and then take the third root. 8 squared is 64. Third root of 64 is 4. But isn't it easier to turn this into a 2? Third root of 8 is 2, and then square it to get 4. I think so. I think this is the easier method. So, root, exponent. Do the root first, then raise it to that power. Okay. Let's try it with some numbers first. Let's convert between exponential and radical form first before we start flying around with a bunch of numbers. So, this one first. X to the 3/7 power. This one's pretty straightforward. Root, exponent. 7th root of x to the 3rd, or the 7th root of x all to the 3rd power. Either way. With a variable, it doesn't really matter. Okay. As soon as we put a number in there, I would do the root first. I would do this method with a number, but with a variable, this one looks actually a little bit cleaner. But most of the time, when we have something weird like this, that is the better way to write it. Okay. Let's try the next one, which is not as straightforward. And I think you can see why. First of all, we have a decimal. Second of all, we have a negative number. To turn a decimal to a fraction is not that hard. And please don't write that this is equal to y to the negative 3 1/2 power. It doesn't work like that. We need a rational exponent. So my rational exponent is going to be negative 7 over 2, 3 1/2. Okay, so negative numbers, no good. So when I have a negative exponent, I get rid of the negative exponent by moving it to the bottom of a fraction. Now I can finally turn this into a radical. It's the square root of y to the 7th. I can simplify that. I told you this one was going to be a little crazier. I can simplify that, and I can do that by splitting it into y to the 6th and one more y, because 6 is a multiple of 2. So that simplifies into 1 over y to the 3rd square root of y. But no radicals in the denominator. So I have to rationalize this by multiplying by the top and the bottom by the square root of y to make this radical complete and not a radical anymore. So this times this gives me y squared. Square root of y squared is just y, and it combines with this one to give me my final answer of the square root of y over y to the 4th. Now, it would have been easier to just leave it in fractional exponent form, rational exponent form, and then just get rid of this fraction. And we'll look at that at the end of this section. So a little bit easier to rationalize with fractional exponents than with a radical. Let's go the other way. This one's a little bit easier. So we're just going to take these two, and we're going to put them into exponential form. Numerator, denominator, exponent, root, a to the 5 over 2 power. Numerator, denominator, exponent, root, b to the 3 over 5 power. And that's it. That's exponential form. Right? We didn't have to rationalize. We didn't have to do anything crazy. We'll get to that later. Right, let's try a few of the gotta problems. Oops. That one got cut off a little bit. That is a 5. Okay, so w to the negative 5 over 8 is the same as 1 over w to the 5/8 power. To turn that to a radical form, that's 1 over the 8th root of w to the 5th power. Okay, well, I can't leave a radical in the denominator. I can't take anything out of this. I can't simplify this at all. So I need to complete the 8th root. And to do that, I need 3 more w's, right? 3 more w's to the 8th root. Because that would give me, on the top and the bottom, that will give me 1 over the 8th root of w, add the exponents to the 8th, which is 1 over, sorry, not 1 over, the 8th root of w to the 3rd. Oof, ugly. But that would be my answer right there. Okay. For this one, a little simpler. W to the 0.2 power turns into a fraction, right? That is 2 over 10, which is 1/5. Okay, so that gives me the 5th root of w. And there's no fractions in the denominator, so for that one, I'm done. That was part A. Okay, for part B, nice and simple here. For part B, exponent, root, numerator, denominator. So that's x to the 3 over 4 power. Numerator, denominator, exponent, root. to the 4/5 power. Okay. Don't be intimidated with the word problem here. The whole point of this problem is just to understand how to put these things into your calculator. Okay. So Kepler's third law of orbital motion shows how you can approximate the period, P, in Earth years it takes to complete one orbit of the sun. So P is going to be equal to d to the 3/2 power, where d is the distance in astronomical units. How many Earth years does it take Mars to orbit the sun? Well, I know the astronomical, see that, right? I know how far away Mars is from the sun. So P is equal to 1.52 to the 3/2 power. That's it. Okay. Now, if your calculator has a nice button that looks like this, and you know how to put a fraction into your calculator, you can just type this whole thing in one set of buttons here, and just press equals and get the answers. Okay. If you wanted to, you could change this to the square root of 1.52 all to the third power and do it that way as well. Personally, my calculator has a button like that, so I can just type in 1.52 and then raise it to the 3/2 power, and you should get the period is 1.87 years. Okay. So be sure that you know how your calculator works in order to get that answer, 1.52 to the 3/2 power. Okay. So again, I think I mentioned at the beginning of this that all the properties of integer exponents apply to fractional exponents as well. That means if you have the same base, you can add the exponents together, just like this. Power to a power, you multiply the exponents together, right? Product to a power, you split them up, raise both of them to that power, just like that. Both get raised to the 1/2 power. Negative exponents go to the bottom of a fraction, like that, and then we simplify from there. Same base, we subtract the exponents, kind of like that, and quotient to a power, you raise both of the pieces to that power. It's 5 to the 1/3 and 27 to the 1/3. 27 to the 1 simplifies, 5 to the 1/3 does not, which is why you just leave it like that. So, if you remember from 6-2, we simplified products or quotients involving radicals only when they had the same index. So if we had something like this, if you had something like this, you couldn't put these together because their index is not the same. Now, however, we can combine rational expressions with a different index if we convert them to fractions, which means this would become x to the 1/3 times x to the 1/2, which would give me, add those two exponents together, right? Don't forget that you need a common denominator, and you get 5/6. So what we couldn't do here, we now can do with fractional exponents. Okay, let's try it. Different index, right? To make this in simplest form, I want to get these two things together. I want to get all the x's together if I can, but I can't do it this way. I need to change this to fractional exponent form and then subtract them because it's division. Numerator, denominator. Over. Numerator, denominator. And even better is that now, without messing around with pulling something out of a radical or doing something weird, I can just reduce this. Much, much better than trying to mess around with this with this radical expression here that I wasn't really able to do anything with. Now, this turns into the top because it's bigger minus the bottom, which gives me x to the 2/4 which is x to the 1/2. And if I wanted to, I could write that back as a radical just like that. Okay? So you can simplify expressions that have different indexes by changing them to fractional, or by changing them to fractional exponent form. Okay, let's try a few more of these. Here we go. 3 to the 1/2 exponent root times 3 to the 1/4, right? Same base. I add exponents together. So that is 3 to the 3/4. Okay, and if I wanted to write this as a radical, I would write it as the 4th root of 3 to the 3rd, which is 27. And then I would just leave it like that. Okay. This one, x to the 1/3 over x to the 2/3, numerator, denominator. Nope, that's wrong. X to the 3/2. Numerator, denominator. 2/3, 3/2. Okay, good. Subtract 3/2 minus, subtract the exponents, and we get 3/2 minus 2/3 gives me 5/6. MC is the same as part A, 7 to the 1/2 times 7 to the 1/3. So I can add those exponents together. So 1/2 plus 1/3 gives me 7 to the, I did that before, right? 5/6, which is the 6th root of 7 to the 5th power. So it's the 6th root of 7 of 16,000 and change. Okay. So now let's get into some more numbers. So we can simplify a number with a rational exponent by using these properties or by converting the expression to a radical expression. Again, do the root first, then raise stuff to an exponent. No good here. So to simplify numbers with a rational exponent, what is each number in simplest form? 16 to the negative 2/5 power, or sorry, the negative 2.5 power? No, don't leave it like that. Change it to a fraction. It's a negative. All that means is put the fraction on the bottom, or put the negative exponent, put that whole term on the bottom. Square root, 5th power. Square root first. So this becomes 1 over square root of 16 is 4. And then 4 to the 5th power is 1024. Okay. Square root first, and then raise it to the raise it to the 5th power. Root exponent. Here, the negative's inside there. Just take the 5th root. Can you take an odd root of a negative number? Sure. So instead of going crazy with this, just take the 5th root of negative 32, which is negative 2, and raise it to the 4th power, which is a positive 16. Okay? Let's try a few more of these. Root, exponent. Fraction first to make the exponent positive. 5th root of 32, we just saw. So that's 1 over 2 to the 3rd, and that's 1/8. Root, exponent. That's 2. 4th root of 16 is 2. 2 to the 3rd is still 8. Here, that's 9 to the negative 3.5. is 7 over 2, which is 1 over 9 to the 7 over 2 power. Root first, so that's 1 over 3 to the 7th power. Calculator gives me 1 over 2187. Okay. Now, that, even though that's crazy, that is much better than trying to take the square root. I mean, you have a calculator, but if you do 9 to the 7th power first, you get 4 million and change. Okay? Much easier to do this first and then raise something to an exponent than making the number bigger. Okay. To write an expression with rational exponents in simplest form, every exponent must be positive, and we follow all the same rules that we did before. We get rid of all parentheses, we get rid of all negative exponents, we put all the variables together, and we break it down as much as possible. So, we're going to do a few of these, okay? And again, the one rule is to never leave radicals in the denominator, which means no fractional exponents in the denominator. Okay, so let's break this down. I don't like this mismatch here, so I'm going to start like this. I'm going to write these as a fractional exponent. X, Y, they're both square roots. That means they're both to the 1/2 power, all to the 2/3 power. I like to simplify inside parentheses first before jumping to this exponent on the outside. So basically, I'm going to distribute this 1/2 product to a power. So we get negative 8x, x to the 1/2, y to the 1/2, all to the 2/3. These two can now go together. Negative 8, x, this is a 1. Same base, add the exponents together. So it becomes x to the 3 over 2, y to the 1/2, all to the 2/3. Now, there's nothing I can do here. So I'm going to do power to a power. I'm going to raise all of these to the 2/3 power. So first this one. Negative 8 to the 2/3 power. Root first, then square it. Negative 8 to the 2/3 power. Negative 8, third root of negative 8 is a negative 2. So that's a negative 2, all squared, which is 4. So this is equal to 4. Power to a power, you multiply exponents. So that is 3 times 2, that's 6 over 10, which is, whoops, 2/3, right? 6 over 6. That's not a 5, that's a 3. Couldn't read my own writing. So 6 over 6, that just turns it to the first power. Okay? Y to the 2 over 6, which reduces to 1/3. And I'm going to leave it like that. I could make this into a radical, but I don't want to. Okay? So just leave it like this. Okay? Again, simplify inside the parentheses first before you start raising stuff to a negative exponent. So this would just turn into 16 over y to the positive 8, to the negative 3 over 4. If I wanted to, I could flip these two and make this exponent positive. So that would be y to the 8 over 16 to the positive 3 over 4 power. Yeah, you could do that if you want. Doesn't matter. Right? Power to a power, multiply exponents. That turns into 24 over 4, which is y to the 6th. 16 to the 3/4 power. Root first. So that turns into 2 to the 3rd. 4th root of 16 is 2. Raise it to the 3rd power. You get 8. All right. So instead of the two got it problems that came with this section, I made some fun ones. Okay. So again, when you simplify with fractional exponents, your answer, only positive exponents, no fractional exponents in the denominator. And you haven't really seen that yet. We did that a little bit way back here. With this one, okay? Now we had to rationalize this, okay? So let's go back and do it with the fractional exponents actually in the denominator. Okay, these problems, they look intimidating, right? They're tough to figure out where to start, okay? Start by simplifying up top, making exponents positive by moving them up and down, make it so there's one of every letter, and then decide if you have to rationalize the denominator. So the first thing I'm going to do is put the two x's together on the top, put the two y's together on the top. In order to add these two, right, need a common denominator. So that's going to be x to the negative 2/3. And then y, so that's going to be 6/4 negative 1/4, right? 5/4, 6/4, positive 5/4, and negative 6/4. Okay, so I'm probably going to move these to the denominator in a second. All right, let's see what happens in the denominator here. Power to a power, multiply, that's x to the negative 1, and then y to the negative 1/8. Okay, so I got a couple things going on here. I really need to decide which exponent is, which number is bigger, okay? So negative 1 is bigger than negative 2/3. So I should move this one, I should move the negative x up there. And so now it becomes x times x to the negative 2/3, okay? And that way the answer will be positive. 1/4, negative 1/4 is bigger than negative 1/8, right? So I should move this one down. So that becomes y to the positive 1/4, y to the negative 1/8. All right, and so now we get x 1/3 over, that's 2/8, so that's y to the 1/8 power. Okay, we've now simplified this expression as much as possible. And this is where you want to get to first. So when you have a problem like this, the first step is to get it down to where every exponent is positive and you have one of every letter, no parentheses, no other things going on. All right. The x is fine because it's a fractional exponent in the numerator. The y is not fine because it's a fractional exponent in the denominator. That means I have to rationalize it. And before I get all crazy turning it to a radical and trying to complete the radical, just make the fraction the next biggest whole number. So if I multiply the top and the bottom by some number of y's, a number that makes 1/8 into a whole number, when I add it to 1/8, maybe like 7/8, because 7/8 plus 1/8 is the next biggest whole number, 1. And now I have x to the 1/3, y to the 7/8 power. Okay? That is now simplified. Okay? This was good. That got it down to the simplified form. This is now rationalized. Okay? And you can't leave this fractional exponent in the denominator. Some of you might be thinking, well, now shouldn't I cancel these two? Well, if you did that, you'd go right back to there. Okay? So once you get it to the place where you have one of every letter and it's simplified as much as possible, then decide if you have to rationalize the denominator. Let's try one more of these. Last one. Okay. So, let's start with the top. So that becomes x to, right, this is 2 over 1, multiply the top, multiply the bottom, x to the negative 2/3, y to the negative 1, 2 over 2, over. I'm going to put these two together. So 1/3 plus 1/2, I believe, was 5 over 6. Y, there's nothing to do with the y. Okay, good. Well, this one's a little bit easier because both of these are positive, both of these are negative. If I move the negatives down to the bottom, I then get some, and you should do this. You shouldn't decide, okay, well, I don't want fractional exponents in the denominator. Get every letter by itself first, okay? So we have x to the 5 over 6. When the 2/3 moves down to the bottom, it becomes positive, so plus 2/3 gives me 3 over 2. And then y 1/3 plus 1 becomes 4 over 3. Right? Both of these, when you move them down to the bottom of the fraction, become a positive. All right, that's where you want to get to. Okay, that's a good answer. It's simplified. I did everything I wanted to. I got rid of all the fractions. I got rid of all the negative exponents. I put all the x's together. I put all the y's together. But the problem is, let me rewrite this, is we can't leave it like this because it has a fractional exponent in the denominator. So I need to rationalize. I need to multiply this expression by something that will make these two fractions not a fraction anymore. And I only want to go up to the next biggest number. So 3 over 2, well, another 1/2 would be 4 over 2, which is not a fraction. 4 over 3, well, 5 over 3 is still a fraction, so 1/3 wouldn't do it. I need 2/3. And you can't subtract. You can't subtract some stuff off. You always got to add. So my answer here is x to the 1/2, y to the 2/3 over x squared y squared. Okay. And yes, this is a little crazy. All right. But simplifying these expressions with these fractional exponents, once you get the hang of it, is not that much more difficult than what we did in the very beginning of this chapter, but with the added bonus of having fractions. So most of these should be no problem, 1 through 6, and you can take a look at the rest of these, but that would be 6-4 rational exponents.